Hello, my friends. Welcome back. We are looking at enhancing the Metro Map project from the WiByte Python curriculum available at www.wibyte.in. Previously, we saw how we could use a function to place these lines in a very flexible manner. For example, I got my scratch line to be, let's say, inclined upwards, my Python line also to be inclined and inclined downwards. In this video, we are going to take this further. We are going to see how we can create turns on this line. For example, look at this picture. Let's say my scratch line goes inclined for a certain time, and after that it becomes, let's say, flat. And my Python line, for instance, inclines after one station, it's vertically down, and then it goes horizontal after that. Now, really, this is quite interesting. Typically, maps do this to accommodate, for example, how the network looks within a city. But from a programming point of view, this is in fact extremely interesting as well because it brings in some new concepts. So that's what we're going to look at in this video. Um, Try to think about how we might do this. Remember, we already have a function which which plots this line for us, which draws this line for us, and there is an input in that function called step, which is a list itself, and it has two values, x separation and y separation. So, for example, we are giving 70 minus 30. We are telling put every station at a separation of 70 from the previous one on the x direction, and say separation of minus 30 from the other station in the y direction. Now, the point is that this list is applied to every station, which is why every station ends up being at the uniform separation. So first thought is that, well, if I want to do something like what I was showing you to create turns and so on, well, all I need to do is to make this a list of lists, and I can say, okay, between every pair of stations, what should be the separation? Sounds quite reasonable. Like I said, we can, instead of giving a fixed separation between stations, we can make step lists, but this could be very cumbersome. For example, let's say we have 8 stations on the line, then we must provide a list with 7 separations of x and y values, a lot of data to be passed around. And the point is, in reality, there may be only say 1 or 2 or say a few turns on the line. Of course, sometimes we have seen maps where we have like a complete circular type of situation, in which case, yes, there are more turns, but in general, I think we need to think of a smarter solution like we'll do here. And that also makes it very interesting from a programming perspective. So the solution that we come up with is that, look, we introduce a new list and we will pass this list as an input to a function. We will call this list, for example, change index. Now, name is okay, but let's try to understand what is the meaning of this list. This list will always have the first item as 0. The reason is I'm saying, okay, look, start drawing my network. For example, in this network, start drawing with a certain separation. At station number 3, change the separation. So basically, this list contains the index of the station where the separation between the stations changes. For example, here it was stations going vertical. At this point, after 3, it's all horizontal. Let's take one more example. Let's say I want to get a situation where I have like some kind of like a, like S shape here. I start at 0, I make my stations move in a certain separation. At 2, this separation changes. So I have a 2 over here. At 4, again, the separation changes, and hence I have a 4 over here. So this list contains the index of those stations where the separation changes. Now, interpreting this list using this in program is actually quite interesting. We can also use this list to, let's say, for example, not change the direction, but change the separation between stations. Like, for example, here, maybe this station 0, whatever it is, it's say very far from all the other stations. This happens sometimes in some networks. So we can say, okay, 0 is here, 1 is here. Now 1 goes in this list because notice the direction is the same, but the separation between 1 and 2 is different. Again, 2 goes in this list because now stations are horizontal. And then finally 5 goes in the list because again the distance between 5 and let's say the last station is, let's say, very small. Now these are just some representative examples, but you get the idea. Let's take an example on how this whole thing might look like. Let's take this, let's say, network as an example. So here I'm saying, okay, look, let's the step change index be 0 and 3. So index will change, the step will change at 0 and then at 3. And step itself is a list of lists. So first I mentioned, okay, what is the separation at 0? And then finally, what's the separation, let's say, at 3 and beyond. So for example, when the program first runs, it picks up, okay, all right, I'm at station number 0. Let me read out this value. So 070, it keeps putting stations at this separation until it encounters a 3, because that's where the separation changes. Now it takes up the next value and starts putting separation, for example, horizontally. So this is what we are going to implement in code. Let's see how we do it, in a step-by-step manner. We will start by asking ourselves a question, okay, I had this function called draw metro line. What is it that I need to change? Let's first identify that, and then we see how we go about changing them. So, well, let's say the three most important changes that come in. Number one, the step itself will become a list of lists, like we just saw here. It contains all the different, let's say, distinct, separation values possible. I will introduce one more list called step change index, and this is basically another list which contains the indices of those stations where the new step comes in. And finally, I need to have some kind of a logic to determine, well, at this station, what is the separation? Notice this information is there, but it has to be processed. For example, at station number 0, 1, 2, in this case, the separation will be 0, 70. For station number 3, 4, and beyond, separation will be 70, 0. Now I can have many more turns, and this whole logic should just keep working. How do we do this? Now, turns out that in order to do something like this, I need to know not only the station name, but also the index of the station. Remember when I'm doing for STN in STN list, I am basically looking only at the value of that list. But by doing this function called enumerate, and I'll give you an example later on so it becomes clearer. By using enumerate, I get not only the value, but also the index. Because here, remember, I'm passing the change index. So I'm going to say, okay, look, let me find out what is the index of the station that I'm presently at. So this enumerate will do that for me. Now it's very simple. I have a variable called change index. I set it to 0. I have a counter variable. I just keep asking myself, look, if my index has become equal to the change index at the first level, I mean, at the first iteration, 100% this will happen. So because the first step is always 0. Remember, I always start my list with 0. So which means I will just read off the first step value. Remember, when I, for example, here, when I am at index 0, I will read off 0. And now I will keep doing this until I hit 3, which means I will keep track of, so basically I say, okay, next step is going to be, let's say, step KK. I will read the X and Y step value because again, next step is a list. 0th value is the X step, first value is the Y step. Now remember, at this point, I need to keep track of, okay, where does this change? And that information is contained in this list, step change. This should be index. There's a typo here. Basically, what I'm going to do is that I'm going to find out, okay, presently my index was, for example, 0. Where is the index inside this list? The next item of that must be the next point where the change must happen. For example, when I start, let's say, this program, I first go to 0. Now I find out that, okay, 0 is also item 0 of this list. Index of 0 in this list is 0. So I go and read this list item 1 because I know that at station number 3, this change must happen. And that will get done, for example, when I reach my index is equal to 3. So when I compare index to change index, it will be 3. Now let's say it turns out that the last station, for example, in this last time we make a change is on station number 3, then this step would fail because the moment index becomes equal to 3, I try to find out the next item. That is going to give me an error. In order to avoid this, because I do not know how many changes there are, I just put this inside a try and except. So I'm telling the interpreter, okay, look, please try to find out. So I'm telling my interpreter, okay, look, try to find out where the next change will happen by saying, okay, look, whatever the present change is, I'll read the next value. But if it turns out that that's the present value is indeed the last one, there's no more change happening, don't worry, don't panic. Just set the change index to, let's say, 1000. Now, 1000 is a large number. Our lists will not be so long, which means this condition will never ever come true. That's the logic. Very beautiful. Once we see this working, it will become more clear. Let's get on with our code and do this. Now, before I start writing any code, let me highlight to you the usage of, say, the enumerate as well as the list of lists, because then it becomes a bit more clear. Remember, I've just run the program. I've stopped it. So I have all the variables available to me. Station SL is my scratch line. It has all these stations. When I do, for example, for STN in, let's say, STN SL, let's say I were to say print STN, we know that it just prints out all the station names, which is what we have been using. But when I do, for example, let's say IDX, STN in, let's say, enumerate, STNSL, I am going to get not just the, let's say, print, I say IDX and STN. If I do this, notice I get the index as well. So that's the beauty of this enumerate statement. It gives me not only the value, but also the index, which is useful for me, as we'll see later. Also, let's just take one more example. Let's say my step, for example, becomes a list of lists. So the way I do that, list, remember, always is a square bracket. Let's just do a dummy here. So let's say I do, maybe say 10, say 10, 20, and then I say, well, maybe 20, say 20, 30. Now notice X itself is a list whose items are also lists. That's why I'm calling it list of lists. If I look at len of X, that is 2. That's because there are 2 items. If I were to see X0, now remember this is the list of lists. So I get another list and then I can further index into it. So that's the idea of a list of lists, which is what we are going to do with our steps. Now let's go back to a function and try to modify it the way we intended to. So I come here and I now introduce, let's say, for example, the new variable that I want to introduce, which is called step chnidx, chnidx, let's say. Now let me make this a little bit bigger so it's somewhat easier to understand. Now clearly the initial position remains exactly the same. However, I'm not going to read the X step and Y step just like that, because now step itself is a list of lists. Remember that, yeah? So the way to do this would be that, okay, I'm going to define a couple of variables. So I just call it, let's say, chnidx. Now this is the variable that's telling me where the change is happening. So I just set it to 0 to start with, because remember, my first step change index is always 0. That's by design. So I just set it to 0 and I use a counter variable here called kkk. I set it also to 0. Now, when I run this loop, I say, well, not only a for loop here, I'm going to say for, let's say, idx, comma, station in, say, enumerate, say, station list. Now, remember, enumerate gives me both the index as well as the name. So we still need the name for displaying, but I need the index as well. So I'm going to ask myself a question. Well, if idx is equal to chn idx, it means that this is one of those stations where a change has to happen. I must go and read what is my step going forward from here. So I call it, let's say, next step. Now, next step itself will be a list and that will be read as step, let's say, kkk. Now I'm using kkk as an index into the step. When I started kkk 0, so which means I first read the first, let's say, list of the step, which is the first separation. Now, next time when I come back here, I will have to read step kkk plus 1, and hence I set kkk equals to kkk, say, plus 1. Now, having done this, I must set the x step and y step. So I say x step is equal to next, say, step, say 0, and y step is equal to, say, next step, for example, 1. That's my x and y step. Remember, next step was a list, so I just assign the x and y. Now I need to figure out, okay, is there, another station where the change is going to happen? So I'm going to put try and except statement here. I'm going to say, okay, look, let me try to find out if there is one more change coming up. So I just say, okay, let me try to, at this point, say change index is given by step change index. And what do I need to find? I need to find out the index of where the idx is and the next element from there. So I'm just going to say, well, step change index dot, say, index, say, idx, and plus 1. So it's like if I read 0, I'll basically and the list was 0 3, so change index will become 3, right? That's the whole idea. But like I said, this could very well be the last element on that list, in which case that statement would cause problems. So I'm going to say, well, not else, say except. So try except, so that way the code is more robust, it won't crash. I just say, well, chn idx is equal to, say, 1000. In fact, 100 also is probably fine, right? Now, apart from this, in fact, I don't need to do anything because everything else is set up over here, right? So x step, y step is being computed and it takes care of itself. But I do need to make one very, very important change, which is that when I call this function now, my step has to become a list of lists. Remember, this was my initial position. My step has to become a list of lists, even if it has only one item. So here the item, there's only one. Let's start with that. This becomes a list of lists. Now I don't want any change to happen in this. So I just put, let's say, for example, step change index is 0. So there's nothing beyond 0. And that's all I need. I'm going to comment out the Python line part. With this code, I expect the same output as earlier. Let's see if that happens. When I run this code, that's exactly what I see. Remember, there is no change happening. So at 0, the step gets read and beyond that it never gets updated. That's why I get exactly this line. Now let's say I want to tell my interpreter, hey, look, please give me one more step at say 70, 0, which means make the line horizontal at station number 3. Now I just put 0 and 3 over here. When I run this piece of code, notice how beautifully the line turns at 3. That's because at 0, I saw, well, the separation was 70 minus 30, so line was going upwards. But I know that the next change is coming up at 3, so when the index became 3, which is this station here, I said, okay, from now on, be horizontal. There was nothing beyond. That's why it stayed. So let's now do the same thing for the Python line. Again, the x in the initial position can remain this way, but this must become a list of lists. Now, let's just kind of play with it a little bit. So I'm going to say, okay, look, for the first position, I want, say, 40, 70. Next, I want the stations to go down vertically. So I just say, for example, make it 70, comma, say, uh, so vertically down, sorry. So I make it say 0, 70. And then at some point, I will make it 70, 0. And this changes must happen at, let's say, so let's create a list here. That's a station change index list at 0 always, at 1, and then let's say at 4. Now this we can experiment and play with. And really, this is all I would do. When I run this piece of code, notice my 0th station does a separation of, let's say, 40, 70. So I get, a little bit of incline. Then at first station, it becomes 0, 70. So it gets vertically down. Then at the 4th station, it becomes 70, 0. So that becomes horizontal. But now we still have one problem to solve, which is that, look, labels here have become on the line. That doesn't look nice. In fact, we would want to have similar flexibility for labels, where I can say, okay, look, my label offset is, let's say, horizontal here, say only changing on X, but at this point it becomes vertical. The way I'm going to do this is, well, I will do the exact same thing on my label as I've done for the, for the stations. But let's see this in another video so that the concept we can again revisit and again hopefully make it more clear. I hope this has been interesting to you. Think through this very carefully. This is quite powerful and the way of thinking is really nice. In general, if you think this way of learning works for you, where we build activities, we think of ways to enhance them, and then we work on enhancements. If you think you relate to this way of learning, look at our website www.wibyte.in, because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.